what we're going for here. We're clearly trying to relate the graph of f with the graph of f prime, and maybe f double prime, and then of course number 3, same kind of relationship stuff going on, but a different focus. These are all old questions. There you go. There's number 1. If you're finishing up C, feel free to do so. There's an answer for 1. Yeah, so my tendency is, like, unless there's arrows on the end of the graph, it looks like it just stops there. So usually, like, if you do a quiz or a test and you tell me, hey, I know what's happening out there if you go to the far left edge of the graph, unless I have a reason to object to that, I'll usually just cross it out and put the end of the domain. I would be careful though, like if there's not an arrow there and you don't know what's happening out to the left, we really just have to assume that we only know about this part. Okay. We really can't say infinity anything. If we had like an analytical presentation of this, like if you knew what the actual x's and y's and squares and all that stuff are, then I think we could definitively say, hey, out there towards infinity, we can see this pattern happening. We just don't know what it is. Others, anything else as far as this particular relationship between f and f prime? Okay, Merrick, if you wouldn't mind joining us here in math class, I would appreciate that. Okay, number 2, there's your answer. Point of inflection at x equals 1.5, and then another one out there at 5, x equals 5. With the corresponding reasoning, please be specific. Please don't try to lump these together and say, because that's where f prime goes from decreasing to increasing or vice versa, or something like that. Tell me exactly what's happening at that particular point and then what's happening at this other particular point. Just want to see that the correct change expressed, whatever that change could be. Anything I can do to help you to understand better number 2? All right then. Here is number 3. So use rigorous notation to show that f prime is not differentiable at x equals 5. So in order to do so, I wrote down some stuff about f double prime, the behavior of f double prime. Because f double prime would simply be the slope, aka the derivative of f prime. Okay, so is your quietness quiet confidence? Or is it a I don't want to ask? Doing okay? I'm having a hard time reading you guys right now. Any questions? Let's remind you of something. Maybe you are in that silent place of I don't want to say anything because everybody around me did fine and I did terrible. Let me just remind you that I'll post video of this just like every other opportunity. It might be worth it to go back and review and hear it again, see it again. Might be helpful.
Mr. Anderson.
Carter.
So why is the interval of 5 to
Which one?
Number one.
Number one. Okay, I want to make sure we're talking about the same thing.
Yeah.
So.
Why would that be concave down?
So, there's two ways to express concavity. One of them is with the behavior of f prime. The other one is with the behavior of f double prime. So we can go fairly deep with this. I would say I'll just address the concave downside. So here's how you could approach it. You could say f is concave down if, there's two options here, two ways you could express this. Number one, if f prime is decreasing, or number two, if f double prime is negative. And these are both based on the fact that prime is simply the slope of whatever you're doing the derivative of, right? Whatever you're priming. So let me draw you a graph of f. We can talk briefly about why this is. Would you agree with me that if this is a graph of f, visually it appears that f is concave down? So I want to use the f prime argument here. So check this out. If I were to select a random point, like maybe right there, I just want your best estimate. What would you guess f prime is there?
2x.
No, I want just a number. What's the slope of the curve there?
2.
Okay, so f prime is 2. So if f prime is 2 there, how about right there? What would you say f prime is?
1.
Okay, seems reasonable. How about right there? F prime is?
0.
And how about right there? F prime is?
-1.
And over here? Okay, fair enough. Do you see how from left to right, f prime went from 2 to 1 to 0 to -1 to -2? Isn't that a pretty clear decreasing pattern? So maybe can you see how a decreasing pattern on f prime means that f is concave down? Likewise, if you saw an increasing pattern on f prime, that would mean that f is concave up. So that's kind of a brief example of the why on the reasoning there. But I would want you at some point to be efficient with that and just say, oh, f concave down, that means that f prime is decreasing. Go, right? Instead of, I need to reprove this to myself every time. From an efficiency standpoint, it would be nice if you didn't have to do that. Okay. All righty, what else can I do to help? Okay. So then, if you haven't already looked at the farmer problem, I want to for sure do 2 of our examples today. And if we get to a chance to explore the third a little bit, that's great. But I want to make sure we at least do the first 2. And if that's all we do, I'm okay with that. So take a look at the farmer. Please read it. And I'm going to encourage you all to do one main thing with this right now. Please draw a picture, like a Google Maps picture of what this could look like. Okay? I'll be doing the same thing. Read about the farmer. Try to draw a picture. I'm going hardcore with my picture. Goodness, Joe, you should sell that to alarm companies. Somebody's breaking into a house and they hear that, they are absolutely going to freak out. That'd be classic. I'm going to go with that. That's going to be my marketing idea, Deca people. Who needs a Ring doorbell when you've got that? If you're watching the video, sorry about that. Hopefully you turned your sound down. Okay. Did you guys draw a similar picture? I've got some brown cows, a black cow, and a black and a white cows. Okay. Whoops. Okay, so clearly this farmer wants to fence in the herd. And so I'm thinking that the fence would maybe look something like this, where you've got one fence there, another fence there, and then the other one right there, forming a rectangular pasture. And it mentions here that there's no fencing needed along the river. I don't know if this is the case or not, but maybe the cows would be... let's just pretend it's a really fast-running river with a cliff to get down to it or something. So they're not going to be crossing the river, right? They could. That also would be bad. No one needs... we don't need to comment on the farmer's intelligent strategy here, but this is what he's doing. Okay, so you okay with the picture? This is if you just read it like a story and tried to draw the picture. We're not getting into any math details yet. You good? I would like for us to be able to kind of proceed using the same variables. Y'all understand that the fencing is a variable? That's really the question. How should this farmer set this rectangle up? So we don't know how long the length or the width is, right? So in math, if we don't know the length, we don't know the width, how do we represent that? Some sort of a variable, like x and y. We can go with that. So I'm going to, or L and W. Can we all try to do the same thing? I don't know how far you guys got with this. How many of you labeled already? Did you use X's and Y's or L's and W's? I'm hearing a lot of X's and Y's, so let's do that. So I'm going to call this side X and this side Y. And the reason why I called them that is because, to me, X being horizontal makes sense, Y being vertical makes sense. You could label it completely the other way, and that makes sense too. So for those of you that drew your picture with the river on the left or the right, our X's and Y's, partway through, are going to seem to be off, but I bet you in the end, they'll be the same. So be patient. This will be a good example for sure. Okay. So I need to figure out here. So it says, what dimensions will require, this is a really key phrase, the least amount of fencing? How do you interpret that? Minimum amount of fencing. Okay, so we want to minimize something. How would you express the thing that we're trying to minimize? Well, we're not trying to minimize the area. I think you said it. It's more of a perimeter concept, right? I mean, the river obviously takes up one side of the rectangle, so it's not really a true perimeter. But couldn't we say that it's the fencing's perimeter? The perimeter of just the fencing? Okay, so we want to minimize the fenced perimeter. Okay. So based on my drawing up there, and let me just encourage you with this. Let's get to a place, I don't know, if you want let me put it like this. If you want your numbers to be the same as mine, let's make it so that you have 2 Y's and 1 X, no matter how you oriented it. Are you okay with that? Because that'll make all the numbers be the same. So how would you guys express the perimeter? I'd say P equals what? 2Y plus X. Agreed. I'm trying to minimize the perimeter. So I feel good about this, but at the same time, I recognize I've got a pretty significant issue. Do you know what that issue is? Like a problem, major problem.
You don't have the variables.
I've got a lot of variables. True. So let's just preview this really quick. Are you guys okay with the idea that if I'm trying to minimize perimeter, aren't I have to find the derivative of this at some point? So here's the problem. I've got to decide, now don't write this down because I'm going to erase a lot of this stuff here in a second. I've got to decide, am I going to do ddx or am I going to do ddy
to this, because it sure as heck makes a difference. So if I did d dx, here's what I would get. I'd get dp dx equals 2 dy dx plus 1. And that dy dx, I don't even know what to do with that. Now dp dx, that's the rate of change of perimeter with respect to the length x. I'm good with that. I'll set that equal to 0 here in a few minutes. But that dy dx, I don't like it. If I tried the other way, if I did d dy, I'd end up with the same issue. I'd get dp dy, again, that's not a bad thing, equals 2 plus, wouldn't it be dy or dx dy? And I don't know what to do with that. I don't have any information about that. I don't even know really what that means. I'd have to stop and think, what does that even mean in the context? So going back to what was said, I think Luke said it, we got too many variables. So what I've got to do is try to figure out a way, before I do any derivatives to anything, I've got to get rid of or replace either the y or the x with something, bless you, that's equivalent. But it's got to make sense. It's got to be logical. Do you guys see anything we could use to help us with that effort?
XY equals 245,000.
The area, right? Yes. So if I know the area is supposed to be 245,000, which actually makes a lot of sense because the farmer would know how much grass his pasture needs to have, I could say XY equals 245,000, and then I could either solve for X or I could solve for Y and then substitute. What do you guys recommend? What do you think would be easier? I'm hearing both, of course. If I solve for X, then I don't have to deal with the 2, do I? So I'll do that. So I'll say X is equal to, can I write it like this? Instead of over Y? Why on earth would I write it like that? I know what I'm about to do, don't I? Yes. Okay, so I'm going to take this and use this to help me substitute. So it'd be now perimeter equals 2y plus 245,000 times y to the negative 1. Okay, so I'm going to let you guys run with this here in just a second, but let me just say this. If you're trying to minimize perimeter, what are the candidates for minimizing perimeter? Endpoints and critical numbers. You're right. I think in the end we're only going to consider critical numbers because wouldn't the endpoints of this be like 0, like he used 0 fence? That'd be one of the realistic endpoints. But that doesn't make any sense because he actually needs some fence. And how long could X get, theoretically?
Super long.
Couldn't it just keep going? There is no real limit to that. So I think because there's not really a realistic endpoint set for this particular question, I think we only focus on the interior candidates, the critical points. Let me just encourage you with that. Find P prime. Think about where P prime is 0 or doesn't exist. And then either use the first derivative test or the second derivative test to justify and prove that you indeed do have a minimum at the particular spot you propose. So let you guys work with that for a little bit here and check some answers and compare notes. I don't know why that just disappeared. Was it 2y plus x? And here we go.
That's not right. It goes from negative. Just so it's not from negative to positive, that means it's from decreasing to increasing. Yeah.
Well, you can't say that because you have to reflect on it because of your square root of y. Everything about this, right? Your square root of y. Your square root of y. You're saying you got this, right? Why do they make this really whatever y square? Yeah.
So guys, I'm just working quietly up here. We can compare notes. And that's 350, isn't it? So did you guys get a y value of 350 for your critical point? Okay. And you only got one, right? There weren't two or three of them? Just one of them? Okay. I'm kind of curious what your opinion is on this. Did you all think that the first derivative test was easier or the second derivative test was easier? First? So this is going to be one where we might differ in opinion, and that's okay. I think second derivative is easier. Here's why. I think I can find the second derivative really fast. So I would say p double prime, make sure that a clear double prime, p double prime equals, it would be 490,000 y to the negative 3. And the reason why I think this one is actually pretty easy, I can say p double prime of 350 equals 490,000 times 350 to the negative third. And I have to admit, I have absolutely no idea what that number is, but I am certain that it's positive. Make sense? I mean, that's a precise number. It's not the finalized form, perhaps, but it's exactly right. And the most important thing about it is that's a positive number. So I can say, because the second derivative is positive at my critical point, I can say that p has a minimum when y equals 350, and that's my conclusion, my justification. I do need to supply the other dimension to this, but as far as proving that I do indeed have a minimum at that particular data point, I've got it. I've proved it, I justified it, I got a good conclusion. And if I remember right, aren't the final dimensions 350? Is it by 700? 700? Okay. So my final dimensions would be 350 meters by 700 meters. And hopefully the farmer and everybody's happy. Okay, so I know it didn't say justify your answer, but I want to be in practice of having stuff like this in the blue box. It's supposed to be a blue box. That's got to be, we want to be in practice of having that. So what do y'all think about questions, comments? Some of that algebra was a little on the delicate side, although we've done some stuff like that before. What do y'all think? Are you as happy as those cows in a big field of grass? Somehow they got erased. I don't know, unless they pushed the wrong button or something. Yeah, whatever. Sir?
I remember doing like problems like this last year in Mr. Briggs' class with like the Norman window. Are we going to do that?
I don't think we're going to do the Norman window, because did you just use the max min finder on your calculator?
Yeah.
We did, I didn't really.
Yeah, I mean, so
I just remember I got it wrong.
so I would say, do you know how like there's, have you ever heard of the concept of games being solved? Like checkers has been solved. Chess has definitely not. Checkers was actually just solved, but a game like tic-tac-toe, it's been solved. A game like Connect 4 has been solved. Like there is a definitive strategy that you can take to win, right? And so with questions like the Norman window, that's been solved. Does that make sense? See if you guys can answer this one. If we could even kind of adapt it to the cow question here, the farmer question. Let's say we had like 500 yards of fencing, and the only requirement is that you have the maximum amount of area fenced in by the fence. Do you know what shape you should use? A circle. A circle would actually take that amount of fencing and maximize the area. Triangle would actually minimize the area. The fewer the sides, the less efficient use of fence. The more the sides, assuming we're talking about a convex polygon, concave, that'd get kind of screwed up, but assuming we're talking about a convex polygon, the more sides, the more efficient use of space. A circle, right? Having like an infinite number of sides. So that's another solved question. So we tend to not do those. You all did this. You've got a piece of cardboard and you cut a little square out of each corner and you fold up the flaps to make a box. Yes? You do this in Algebra 2 and Pre-Calc? Like it's been solved, right? Like it's like it's something that could just be memorized essentially. And so we're going to stay away from those because we want you to be, I want to try to make you as original of a problem solver as possible. Right? Like, hey, here's a scenario you've never heard of before. Can you do it? That's where I want to go. That makes sense? The Norman window is interesting. That's like the rectangle with the round top part. Yeah, that's interesting. I completely agree. But we're going a little different direction as far as problem solving goes. Still interesting. Hey, if you haven't already looked at the concert question, I'm really curious to see what you all do with it. There's one particular detail. Yeah, there's one particular detail that I'm curious about. So please try the next one, the concert question. I'll scroll to it too. It's right here. It says the concert is beginning soon and people are starting to get in line. The rate at which people join the line is given by J of T. People per minute. The rate at which people leave the line and go into the concert is 7 people per minute. For non-negative times, when is the line the shortest? This is definitely calculator active. I don't think it really requires a picture. But I'll let you run with this for a little bit. And this is not the thing that I'm curious about. Do you all recognize that this is just a different version of the water tank question? We're not talking about water in a tank. We're talking about people in a line. But this is the water tank question. You don't know.
What the rate of people leaving at 0 or entering is
Do you know? Say again? Say what you just said?
the rate of people joining the line at 0 is 0, but the rate of people leaving the line.
But I never at any point told you how many people were in line at T equals 0. Have you ever showed up to go to some event and you feel like you're going to be the first one there at your T equals 0 and there's already like 100 people in line? So there could be 100 people in line at the very beginning. In fact, there almost assuredly is more than 0.
But I used it the first grade test and that also. Yeah, I know, but got 0. 7? It's just 7. Wait, no, I didn't. Yeah, I didn't.
This is not intended to be a tricky question. Like there's like a gotcha. That's not intended to be it at all.
I just did it wrong. No, I did it wrong.
You'll see the rate of people going in and the rate of people going out, essentially. The rate of people joining the line, the rate of people leaving. Calculator active, so once you get something good, please use your calculator to help you sort through the details quickly.
That's good. I get bamboozled by this question.
Say again?
If I get bamboozled by another question like this.
Bamboozled. Well, I can see that you only used 2 decimals, so I don't know if you consider that bamboozling, but you need at least 3.
Oh, no.
Let's make that a habit.
Yes.
3 or more works for me, so that works for the AP folks as well. This is calculator active. Don't be shy about using it. What kind of thing is J of T, Caitlin? What kind of thing is the other number? Why are you differentiating? Yes, but no?
Like I get it, I just don't know.
Oh. What does R stand for? So maybe like net rate? I can buy that. So so it says, when is the line the shortest? What is minimum length of line? So wouldn't you say that that is your net rate of the length, net rate of change of that correct? So when you're trying to find a minimum rate, where do your candidates come?
Because I have 32.115.
And what's yours?
He has 32.1155.
Yeah, with the net rate of 0,
you're talking about doing a derivative. So why did you, so JFT is equal to this. Why are you telling me that JFT equals that? You changed it a little bit. So isn't this the rate of people entering the line? Yeah, so I think you want to combine those, but the combination of those is not JFT. It's something else. I mean, you don't necessarily have to do that, but I wouldn't call that combination JFT. Label it with something else, yeah.
I'm gonna call it this is how
Oh, there you go. That's fine. That's fine.
And over in Miller, how do you like the based stuff?
If you're gonna use LOT, make sure you're telling me that. Just assume that all
From the
know.
derivative, how do you solve for t?
Okay, let's talk about a solution here. The first one is this. The first thought that I think is worth talking about is right here. Did you all recognize that J of t is already the rate that we want to use to help us? In other words, there's no need for us in this question to find J prime. You catching on to that? And did you also notice that 7 people per minute similarly is already the rate of change of people leaving the line, so we don't need to try to differentiate that either. That's already the rate of change of people in the line. So we just need to leave those as is and combine them into something. Did you guys do J of t minus 7 to express the net rate? So that's the net rate of change of the number of people in line. So I'd start there. And if you want to label that and say, hey, that's R or N for net rate or something like that, it's totally fine. You don't have to do that. What I am going to say you have to do is this. Don't we have to consider where the net rate is 0 or DNE? On the DNE thing, I think for our domain, I think we're in the clear there. Obviously, the 7's not an issue. And as long as t is greater than or equal to 0, I think the natural log function will exist as well. So I think we can just say equals 0. And as I walked around, I noticed a lot of you went here. You said, all right, 2 natural log of t plus 1 minus 7 equals 0. And there was, like adding 7, dividing by 2, e both sides. All that was really good math. Do you realize you can just graph this and solve it without doing any of that stuff?
What's the fun in that?
I don't know. I personally would be on your side in a case like this. I feel like I could probably do it in about the same speed, to be honest with you. But when it gets way more complicated than this and you look at it and you say, golly, I'm not even sure anybody could solve that. You better be using the calculator, right? That's a totally okay thing for you to do. It's not cheating. It's not anything bad. It's all good. So whatever you did, whether you did the whole algebra stuff or you just went to the calculator, is this 30-something?
32.115.
32.115. That sounds about right. Do you guys agree with Reese's number? Okay. So what is that? Like in the grand context of thing, what does that number even mean? 32.115. That's it's a critical point, right? That is where the net rate is 0. And so that is, I think that's the only one, right? So that is the only potential place where the line is shortest. That's the only potential time when the line is shortest. What did you all think about a first derivative test or a second derivative test? Which did you think was easier? Second was easier?
Yeah.
Okay. So let's see here. If I did my second derivative, that would be what? 2 over t plus 1 minus 0. Okay, so then I would say 2 over 32.115 plus 1. Again, I have no idea exactly what that approximately is, but I do know that that number is?
Greater than 0.
Yes, it's definitely positive. So because that number is positive, what judgment can I make about the length of the line at that time?
There's a relative minimum.
So yeah, the line length would be concave up, and the line length actually would be minimized, right? So we can say, therefore, the line, or we could say maybe the number of people in line is minimized. at t equals 32.115. So first derivative test would have worked fine. Second derivative test obviously worked fine as well. Really, unless you're otherwise directed, it's your choice. Totally your choice. Okay. Thoughts or questions there? Okay, so I at least want to give you a shot to look at this one and just do some thinking about this last one. This would be an excellent extra practice question for later on. A continuous function that we never really understand what it is exactly on the interval 0 to 7. And then you've got a rate in and you've got a rate out. The rate out is piecewise. I think before I asked you the question, for what interval is the amount of water increasing or decreasing or something like that? So here the question is, at what time t is the amount of water in the tank the greatest? So any thoughts on how, like I said, we're just maybe going to get a setup here, and then you could continue this later if you want, and I could post an answer if you want as well. If I'm looking for critical points, right, how do you think I would find critical points?
Set the net rate of change for each scenario. So F2 minus G of T for which G of T for the first case would be 250 if it's in the interval 0.
Let's just go generic like you started off with. You said f of t
minus G of T.
minus g of t, and where would I go with that?
That would equal 0.
Okay, does that part make sense? Net rate equals 0. And f of t is the rate coming in, g of t is the rate going out. And of course, Reese pointed out that depending on which piece you're looking at, it's either going to be f of t minus 250 equals 0, or f of t minus 2000 equals 0. I'll leave you with this last thought before we go. On the graph, where would the critical numbers be represented?
Intersection.
The intersection points, yes. Can anybody see a place where the net rate wouldn't exist? Right there at 3. So you would actually have 3 critical points within this interval, 3 critical points on the inside. And if you just considered the sign changes, right, I think probably the first derivative test would make a lot of sense here. You could see where you'd have a max or a min. Fair enough? Okay, cool. Well, that's our time. So head on out. See you tomorrow. Antiderivatives. Just a reminder as this week goes on, great time to do retries on quiz 10. We'll be doing quiz 11 on Thursday. See you guys tomorrow.